Welcome to Rai University. Myself, Dr. Pavan Shah, Assistant Professor in Rai School of Engineering, welcomes you all on today's lecture based on the computer graphics. So now, in the current era, we know and observe there are so many graphical representation was there in image. We need to use in 2D and 3D structures of image to make out the function in the real world. So the animation is nothing but the function of itself. Now, let's understand what is in computer graphics. Computer graphics is a subfield of computer science which used to generate something. The generation is based on the certain values of pixels makes a function itself. So the image is nothing but the combination of pixels. We need to use and manipulate itself on the pixels and working as a rendering function on it to make out the animation and visual context to be an analyzed function towards the values and ethics. So whatever the function we are using in terms of images, that all representation of the games, films and all medical emergencies eras, just like an X-ray and MRI, that is a true computer graphics. We need to make and make out the certain functions and based on the same. So the computer graphic refers to the several things that already being included. The first is called the manipulation and representation of the image. We need to create an image based on the pixels and values to cancel it out the entire films of representation. The various technologies are required to work as creation and manipulation. So whatever the manipulation happens, this will change and work together as one divine work of the creations and manipulation of the pixels. The next is the part of the synthesis, digital synthesis and manipulation also being happens. So whatever we do it on the cropping side, clipping side, viewing side itself on the computer graphics. So now let's understand the types of computer graphics. The first type, the foremost, is called the raster graphics. So whatever the function we will use in terms of viewing the entire image of this work as a raster graphics. The raster graphic is a combination of pixels that used to image to be drawn. So there are certain graphical pixels and makes this pixel we need to create the entire image. It also sometimes it's known as bitmap image. That is a sequence of image just like a frame. The number of frames together make the smallest picture and make and large and together work. Now the vector graphics are the mathematical calculation formulas which need to use and draw the different shapes, lines and objects. So in the image, whatever the function oriented informations are there, we need to make it through the vector graphics. Through the raster, we need to only map the pixels value. Through the vector graphics, we need to adjust and entire the every scale conversion methods. So why computer graphic is used? So we have an imaging system. So Image One car manufacturing company that wants to showcase its vehicle sales over the past decade. So many times it will selling it up. By storing the presenting the huge amount of data, it's a time consuming. So whatever the function they use it in such a memory intensive matter to be create and enhance the particular system. By doing it, the plotting the graph and visualizing that we need to show the our car is behave in interactive manner. So through this technique of interaction computer graphics, we have to be in two-way communication has been happened to the users and the computer side. So now let's understand the basic difference between the raster graphics and the vector graphic. The raster graphic is made up of with the composition of the pixels, while the vector graphics makes the path values, means two pixels are distantly behave in terms of Euclidean methods. In raster graphic, process is an independent complexity of the image, while vector display is a function of image to create for the long time. While the raster is basically based on the output primitives, while vector is behave as a scan conversion not being used for the rastering output devices. Now raster graphic cost is very less because it contains only the pixels value, while the vector graphic is comparatively more expensive. Now through the raster graphic we need to use the mathematical operation to be work for as an approximation structures, while the computer graphic is just by showing the graph and line itself. Now raster is depend upon the size of the image or the quality of the image. We need to extend our version of BMP, TXT, GIF, JPG, context format, while the vector is basically based on SVG, FES and PDF format. Now let's understand why we need to use the display model of the image. Through this CRT concept, we need to understand on the 11th standard, it will shown up the values of display circuit on the system. So what is a cathode ray tube? Cathode ray tube is a television based or computer screen based inside electronics produced image system which need to be sense and free to do whatever the work has to be done in the image. So what happens here, we need to have a control grid. The control grid has an values to pass the system on the image through an electronic circuit where the heater is producing the values. The cathode ray tube is expanding their values and converted into a defective coil. This coil is transmitting certain electronics beams or electrons on the fluorescent screen or the magnification screen to be displayed as a one system of module. So this is concept is nothing but called as an electronics gun. We need to use the vacuum tube to produce an electrons and transfer to the image system to display on the fluorescent screen. So whatever the electronics beam is producing the electron, that vacuum tube contain one and more electron guns inside. So we have two types of cathode ray tube is being there, the monolithic and the chromatic, which is the electronic based system to transfer the beams and manipulated display image on the fluorescent screens. Now whatever the function happens through the cathode ray strips, we have the two types of, the first is monochrome, the second is based on the color CRT. Now the color has a value of single color, either black and white. So we have only the black and white color need to be run on the display side, while the color has a full affection of the beams. Now in the electronics gun, in monochrome system, we have only one electronic gun is present, while the color have three electronic gun which is made up of with the RGB colors. Now monochrome is majorly uniform in the layer of phosphorus sides, while the color is based on the pattern valuation based system. The cost is low here, the high color resolution color TV is used, so the device will use to be higher in model. The power uses is lower. In the colored CRT tube, the power uses is high due to the transmission of the electronics beam. The complexity was there in the color because we have three color gun, the producing the three colors at the same time, while the complexity on the monochrome is just like a one shot at the time to produce an electronic gun. Now many a time we observe currently in the era the digital system is going to happen on the time the color tube is producing the red, green and blue color to check and validate the system. The system is work as the feature module and models of love. Now we need to use this method to analyze the complete system through the RGB models. We have three models, the R, G and B. We need to use x-axis as a R, y-axis as a green and z-axis as a blue. The coordinator system are first is behave as x, y and z. So we need to use this coordinate system to point and plot it out the red color. Among them the green is the same 0 1 0 and the blue is the same 0 0 1. So three coordinates are making up the entire 3D module systems. Now apart from that, on the gray line of axis, the black is behave as a 0 0 0 while the white is behave as a 1 1 1. So now whatever the 256 combination we are using till 0 to 256, the 0 is called the black, the 256 it's called the white. The entire system is made up of with these two colors. Now in terms of equation itself, we have two types of color model. First is red, green, blue. The second is CMY, cyan, magenta and yellow. So red is completely opposite towards the fundamental, it's called the cyan. So basically R is present in the x-axis, so whatever is not present in the x-axis, this phenomena are considered as a cyan. So this value is 0 1 1 because x-axis is not present. At the same time, in the green, the opposite, the magenta was present. The opposite sharp, the magenta was present. The value is 101. So because the y-axis is not present due to the reasons of green. At the same time, in the blue opposite, we have a yellow. Blue has 0, 0, 1. In the yellow fundamental, we have 1, 1, 0. So basically, the entire color model will reflect the certain values itself. Now, technically, we observe we have 3 bits and 3 bits has total this many values. Now, this is called as black. This is called as white. Now here 001 means it is called as blue. In the middle 5, it's called RGB, so it's called green. Here it's called red. X-axis is not present, Y and Z is present, is called the cyan. Y-axis is not present in the system, means it's a completely opposite to the system, it's called the magenta. Z-axis is not present, means completely opposite to the blue, it's called yellow. And 111, it's called white. So whatever the basic fundamentals of digital system we have, we need to map the entire phenomena on the same line. Now through an RGB model, we need to easily create CMY model. This is a completely opposite system to create and manipulate the work itself. So we also make a cyan, magenta, yellow system. We need to use the coordinates of x, y and z, x-axis, y-axis and z-axis to create the CMY model. So this is a completely opposite model to the computer graphics. Now the last for the most thing we need to understand is the RGB concept. So whatever we need to store the color model, this model will store into the lookup table. Now lookup table has a facility of 2 raised to power 3 modules and 0 to 255 storing capacity of the color. It will shows based on the R, G and B values and mapped it with sequentially, and it will run and work as model. So this is a lookup table. We need to represent this lookup table in form of values. At the same time, we have n cross n model values, and this model has m intensity level. So we need to create n cross m minus 1 plus 1 values of the color intense level on the particular pixel by using the model of RGBs. At the same way, we need to use an width cross height model image by using a combination of this RGB values. Till now, I hope the RGB model concept is clear. I hope you like the session. I hope you understand well in terms of computer graphics.